Hello everyone. Once again I welcome you all for the online digital class. Today we are going to review about Introduction to Algebra, what you have studied in your 6th class, and learn about a new topic, algebraic expressions. So let us start the lesson. At the end of the lesson, the students will be able to define variable and constant, explain the formation of algebraic expressions, identify factors and coefficients of a term, find the value of an algebraic expression, and discuss addition and subtraction of algebraic expressions. So you might have studied in your classes about variable and constant. So let us review about this. Here you can, as you can see, 2, 7, 9, 28, 1, 5, root 5, etc. are the values that does not change. So these are called constants. And in this, if you see here, x, y, z, p, q, r, l, m, n are the letters used to represent a value. So these are called variables. And these constants and variables combine to form terms. If you observe here in this slide, what do you notice? Children, we notice that there are 4 yellow colored tiles, which pattern is written as 4 into 1. And if you observe one more thing, there is in the middle there is one more slide in between the 4 slides here. So the total number of slides are 4 plus 1, that is 5. So what do you observe here? The pattern can be written as 4 into 1 plus 1. Similarly, the number of yellow tiles here, as you observe, are 8. So 2 on each side of this slide tile, 2 on each side here, 2, 2, 2 and 2. So 4 2s are 8, and one slide in the middle, that is 4 into 2, 8 plus 1, that is total number of tiles are 9. So now number of yellow tiles are 8, pattern can be written as 4 into 2, total number of tiles are 9, pattern can be written as 4 into 2 plus 1. Similarly, here also we can notice that the number of yellow tiles, as you see, are total 12, 3 on each side here and 1 in the middle. So total there are 13 slides. So here 3 into 4, 4 sides, 4 multiplied by 3, 12 slides plus 1. So what do you notice here? Number of yellow slides are 12, pattern can be written as 4 into 3, and number of total tiles 13, whose pattern can be written as 4 into 3 plus 1. So that is 13 tiles. The patterns, as we have seen, are 4 into 1 plus 1, 4 into 2 plus 1, 4 into 3 plus 1, and so on. So how do you write an expression for these patterns? As you can see here, the above patterns can be written in the form of an algebraic expression, that is 4 into n plus 1. As the value of n here, it keeps on changing, as you can notice, 1, 2, 3, 4, 5. It is a variable and plus 1 is a constant. So 4 into n plus 1. So we can say that an algebraic expression is a combination of constants or variables using arithmetic operations. Let us observe a table in which we will take a statement and write it in the form of an expression. As you can see here, 3 more than n can be written as n plus 3. Next one, m is reduced by 4 can be written as, reduced means subtracted, that is m minus 4. Next one, 8 subtracted from a, that is a minus 8. Q multiplied by 7 can be written as q into 7. Next one, y divided by 9 can be written as y by 9. 1/4 of the product of p and q, as we all know, product means multiplication. So 1/4 into p into q. Next one, 2 added to 3 times of z, that is 3 times of z can be written as you can see here, 3 into y, times means into 3 into z plus 2. 7 subtracted from 2 times of k, that is 2 times of k, as you can see here, 2 multiplied by k minus 7. Y multiplied by 10 and added to 13, that is y into 10, and this expression is added to 13. So we can express it as 13 plus y into 10. Next, write the following expressions as statements. So let us see how do you express the expressions in the form of statements. X plus 3, this can be written as 3 more than x. Y minus 7, 7 less than y, or this can also be written as 7 is subtracted from y. 10 n, 10 times n, or 10 multiplied by n, or the product of 10 and n. X divided by 2, x by 2. Next one, 3m plus 11, 11 added to 3 times m, or 3 multiplied by m and then 11 added to it. Next, 2y minus 9, 9 subtracted from 2 times y. Algebraic term and numeric terms. For this, we take an expression 2x plus 9. Children, now as you can see here, 2x plus 9, you have two terms. They are here in this first term 2x, you have a variable and a constant, so it is called an algebraic term, and 9 is a numeric term. Now next, one more expression, 3x square minus 11y. Children, can you say how many terms are there in this expression? Yes, we have two terms in this expression. Now 3x square is one term and 11y is the other term. Similarly, we can write n cube as the multiply n 3 times, that is n cube is equal to n into n into n. Terms of an expression. What are the terms of an expression? Now let us see here a small example where I considered an expression 9x plus 4. How do you write this expression? First, the first term is formed here by multiplying 9 by x and then adding 4 to it. So we can write this as 9 into x plus 4. How many terms are there here? Children, we have two terms. 9x is one term and 4 is the other term. Now as you see here, 9x and 4, they are called terms, and terms are added to form expressions. Next, one more example, 5x plus 3y. Now children, can you say how many terms are there in this expression? Yes, there are two terms. The terms are 5x and 3y. Now 3xy. Now let us see what are the factors of that term. For this, I have taken a small example here, 3xy, whose factors can be written as 3, x and y. So now let us take one more example here, that is an expression having two terms, 5xy plus 10. So now as you see here, what are the terms of the expression? Here you can notice 5xy is one term and 10 is another term. Now one more thing you can notice here, 5xy can be split as factors as 5x and y. So next one, we will go for what are the coefficients of a term. Now in this, consider a small term 5xy. What is the coefficient? Now as you can notice here, 5 is a number, that is the numerical factor of a variable term is called its coefficient. 12x square plus 4xy plus 7y square is an algebraic expression having three terms. The coefficients in this expression are 12, 4 and 7. Now what are like terms and unlike terms? Now let us take when terms have the same algebraic factors, they are called like terms. As you can see here in this example, we have two terms 3mn and 10mn whose algebraic factors, as you can notice here, are m and n. Here also we have m and n. So the algebraic factors are same. They are called like terms. When terms have different algebraic factors, they are called unlike terms. For example, here you can see 3x, 7b are two terms. In these two terms, if you observe, here the variable is x, that is algebraic factor, and here it is b. Are they both same? No, they are not same. So they are called unlike terms. Now what is the coefficient and how do you write the coefficient of a single term? Children, let us observe a single term here 9xy and how the coefficients are written. So first let us take 9 is the coefficient of xy, you can say. Why children? Because 9xy can be written as you can see here, 9 into xy. Next, x is the coefficient of 9y. As you can see once again, 9xy can be written as x into 9y. Next one, y is the coefficient of 9x, as 9xy can also be written as y into 9x. Next one, 9x is the coefficient of y, as 9x y can be written as 9x into y. Here 9x is the coefficient. Similarly, 9y is the coefficient of x, as you can see here 9xy can be written as 9y into x. So here 9y is the coefficient. Next, one more way of writing the coefficient is xy is the coefficient of 9, as 9xy can also be written as xy into 9. So here xy is the coefficient of the term. In 9xy, 9 is called numerical coefficient as it has a numerical value. X, y and xy are literal coefficients because they are variables. Now, an algebraic expression is a combination of constants or variables using arithmetic operations. As you can see here, example x plus 5. Here the operation used is plus. In this, 3x square plus 2x minus 7 is also an algebraic expression having three terms. Here the operations used are plus and minus. And one more example, minus 5x square plus xy. Here also you can see two terms are combined. Addition sign in between them. Types of algebraic expressions. Now we will see how do you say or how do you bifurcate, differentiate the terms, algebraic expressions using their terms, number of terms. So as you can see here, for example, x is a single term, 7xyz is also a single term, 3x square y is also a single term. So in these three expressions you have one term each, so it is called a monomial. A plus 4x, x square plus 2y, 3x square minus y square. These three expressions here, as you can see, have two terms each, two unlike terms each, and it is called a binomial. Next one, ax square plus 4x plus 2, 7x square plus 9y square minus 10z. How many terms are there, children, in these two expressions? We have, yes, three unlike terms. So it is called a trinomial. 4x square plus 2xy plus cx plus d, and one more is 9p square minus 11q plus 7r plus t. In these two expressions, if you see, you have more than one unlike terms. So it is called a multinomial. So one term monomial, 2 unlike terms binomial, 3 unlike terms trinomial, more than 1 unlike term it is multinomial. And a small note you can see here, children, please observe carefully, binomial and trinomials are also multinomial algebraic expression. Now do this. You can give 2 examples for each type of algebraic expressions and identify the expressions given below as monomial, binomial, trinomial and multinomial. You can see here 4 examples are given. In this first one you have 3 terms, so it is a trinomial. Here you have 1 term, so it is a monomial. Here in this expression you have 2 terms, so it is a binomial. In this last expression we have 4 terms, so it is called a multinomial. Next, we will consider a small table here where I have taken some algebraic expressions and what is the degree of the monomial. How do you write the degrees of the monomials? As you can see here, x, it is a single term where the exponent of x is 1, y is 0, z is 0. So the degree of this monomial is 1. 7x square, exponent is 2, y exponent is 0, exponent of z is also nil. So the degree of the monomial here is 2. Minus 3xyz is also a monomial. Exponent of x is 1, exponent of y is 1, exponent of z is also 1. So the degree of this monomial is 1 plus 1 plus 1, that is 3. 8y square z square. Here you don't have x term, so the exponent of x is not mentioned. Exponent of y is 2, exponent of z is 2. So the degree of this monomial is 2 plus 2, that is equal to 4. Degree of algebraic expressions, monomial. Let us take one more example, 9x square y square. So how do you write the degree of this particular expression? It is the sum of these 2 exponents. The exponent of x is 2 and the exponent of y is 2. So the degree of this term 9x square y square is 2 plus 2, that is equal to 4. The sum of all exponents of the variables present in a monomial is called its degree. Next, degree of a constant term. Since we all have studied in your lower class that x to the power of 0 is written as 1, so we can write 3 as 3 into x to the power of 0. So thus the degree of 3 is 0, and since 3 is a constant term, we can say that the degree of a constant term is 0. Now the highest of the degrees of all the terms of an expression is called the degree of the expression. Next, here we will take a small table and see how do you write the degree of different algebraic expressions. First one, 7xy square. If you see here, it is a monomial expression. So here the exponent of x is 1, exponent of y is 2. So if you add these two, 1 plus 2 is 3. So the highest degree is 3. So it is called the degree of this particular expression. Second one, 3y minus x square y square. Here the exponent of y is first term is 1 and the exponent of the second term is 2 plus 2, that is 4. So the highest degree in these two is 4. So we can say the degree of this particular expression is 4. Next one, 4x square plus 3xyz plus y. Here as you see, the exponent of variable x is 2. The second term 1 plus 1 plus 1, that is 3, and last one it is 1. So what is the degree of highest degree here? 3. So the degree of this particular expression is 3. Now pq minus p square q square plus p square q plus 9. In the first term you see 1 plus 1, the degree is 2. In the second term it is 2 plus 2, that is 4. In the third term here it is 2 plus 1, that is 3. And the fourth term here it is, since it is constant, it is 0. So in these 4, the highest degree is 4. Degree of this particular expression is 4. Now addition and subtraction of like terms. Now let us consider 5 pencils have taken here and 3 books. So can we add these 3 books to these 5 pencils? Children, can we add them? No, we cannot. Why? Because, or can we add these 5 pencils to these 3 books? No, we cannot do it. So we can say that these two cannot be added since they are not same objects. Here you have pencils, here you have books, they cannot be added. Similarly, we will consider 5 pencils and here 3 more pencils. Now, can you add them? Since these two are same kind of objects, they can be added. So, what can you say? The like terms can be added or subtracted. Now, let us find the sum of the algebraic expressions. 3x comma 7x. 3x plus 7x. If you want to find the sum of these two, we will add only the coefficients of the given terms. So here it is 3, here it is 7. So 3 plus 7 times of x, that is equal to 10x. Next one, 18ab minus 12ab, 9ab is equal to, here the coefficient is 18 minus 12 plus 9. Add these 3 coefficients and ab as it is. So we can, if you add, we will get 15ab. Now subtract the first term from the second term. Now you can see 12y and 3y. The second term is 3y. We have to take away the first term. So 3y minus 12y and write the coefficients 3 minus 12 times of y. 3 minus 12, as we all know, it is minus 9. So this can be written as minus 9y. Next one, 6ab minus 12ab. Minus 12ab, from this you have to take away 6ab, that is minus 6ab, and here you can see minus 12 minus 6 times of ab, which is equal to minus 18ab. Now simplify. One more example, children, let us consider, see, 5x square plus 10 plus 7x plus 4 minus 3x plus 3x square plus 8. Now we'll arrange these terms by grouping the like terms together. 5x square and 3x square are like terms. Next one is x terms, both 7x minus 3x. Next one, 10 plus 4 plus 8. After grouping these 3, we'll add these expressions. 5 plus 3 is 8x square, 7 minus 3 is plus 4x, and here you will get plus 22. Now let us consider a small table and see how do you write the expressions in their standard forms. Now 3x plus 7x square minus 9. Now I'll arrange these terms as you see in the descending order of their exponents. So I'll write 7x square first, then next plus 3x, last one minus 9. So this is called the standard form of this particular expression. Next one, minus 2m plus 6 minus 3m square. So you can write this as minus 3m square minus 2m plus 6. The last one, y cube plus 1 plus y minus 3y square, that is y cube minus 3y square plus y plus 1. So this is called the standard form of this. Now let us see how do you find the value of an expression. 3x square at x is equal to minus 1. Now let us substitute minus 1 in place of x here. Substitute means in place of x we will write minus 1. Minus 1 whole square, that is 3 into 1 is equal to 3. Next one, x square minus y plus 2 at x is equal to 0 and y is equal to minus 1. If you substitute the values in place of x 0, that is 0 square minus as it is, in place of y you will have minus 1. So minus of minus 1 plus 2. So it is 1 plus 2, that is equal to 3. Now how do you find the area of a triangle? Given the formula is half base into height, where the base is given as 12 centimeters and the height is given as 7 centimeters. Now let us see, area is equal to half into, in place of b here we will substitute the value of b 12 into, in place of h here we will substitute the value of h, that is 7. So we will get it as 42 square centimeters. Now how do you add algebraic expressions. As we have already learnt that like terms can be added, now we will see how do you add them. Add 3x square plus 5x minus 4 and 6 plus 6x square. Now we will take two methods are there for doing this. First one, column method or vertical method. Now let us write both the expressions in their standard forms, and the second expression in the standard form, 6x square first plus 6 at the last. Now if you add these two expressions, 3 plus 6, that is 9x square, here plus 5x as it is, minus 4 plus 6 gives you plus 2. Now row or horizontal method, 3x square plus 5x minus 4 with a plus sign in between, plus 6 plus 6x square. Now we will regroup these terms, the like terms, together, that is 3x square plus 6x square as one group, 5x as a single term, minus 4 plus 6 as one more group. Now if you add here 3 plus 6 coefficients are 9, that is 9x square plus 5x as it is, minus 4 plus 6 gives you plus 2. Next, what is the additive inverse of 6x square minus 4x plus 5? Now you have learned in your lower classes that if you take a natural number 5 and add minus 5 to it, that is 5 plus minus 5 is equal to 0. So the additive inverse of a positive integer is a negative integer. Now this expression additive inverse is negative sign for all the terms in the expression, that is minus 6x square, here minus 4x becomes plus 4x, plus 5 becomes minus 5. Now subtract 3a plus 4b minus 2c from 3c plus 6a minus 2b. Now this second expression is not in the standard form. So children, what you have to do first? First we have to write this expression in its standard form, then subtract. So writing this expression in the standard form is 6a minus 2b plus 3c. From this we have to subtract the first expression. For subtractions, change the sign of the terms, that is here it is plus, it becomes minus, here it is plus, it becomes minus, here it is minus, it becomes plus. That means we are writing the additive inverse of this expression, and now we will add both the expressions. 6 minus 3 is 3a, minus 2 minus 4 is minus 6b, plus 3 plus 2, that is plus 5c. So the answer finally is 3a minus 6b plus 5c. So this is column method or vertical method. Now subtract 3a minus same from 3c plus 6a minus 2b. So we'll write this expression first. We have to subtract. So we'll take a negative sign in between and write the first expression, 3a plus 4b minus 2c. Now if you write the additive inverse of the second expression, write the first expression as it is. Additive inverse of the second expression, plus 3a becomes minus 3a, plus 4b becomes minus 4b, and minus 2c becomes plus 2c. So we'll write, as you see here, once again we have to regroup the like terms. So like terms are here, as you notice, 6a and minus 3a, minus 2b and minus 4b, and 3c plus 2c. So 6 minus 3 times of a plus minus 2 minus 4 times of b plus 3 plus 2 times of c. 6 minus 3 is 3, that is 3a, minus 2 minus 4 is minus 6, that is minus 6b, 3 plus 2 is 5, so it is plus 5c. So the final answer is 3a minus 6b plus 5c. For better understanding of the concepts, please visit the site SERT and you can download the worksheets and practice them at home. Thank you very much.